Alright, to answer your questions about how to go about doing these type of problems that you sent me. Now, to study our graph here, to get our trilinear inequality, go ahead and pull up your point estimate for a confidence interval spreadsheet found in chapter 8. Now, what we're trying to do here is figure out our lower, which is right here when we calculate this and type this all in the spreadsheet, and we're trying to calculate our upper, which is found right here. So doing that, we have the male students who would receive a grade of C, so we're going to go ahead and type in 9. We're going to go ahead and type in the total amount of male students, which is 33. Our confidence interval, which is 90. Now, we have to go ahead and manually round our P calculation as well as our MOE calculation. So, rounding our P calculation, we get 0.2727 because it asks you to manually to the place your problem asks you to, which it's asking us to do 3 or 4 decimal places usually, so I'm going to go ahead and just I'll do 3 for good measure. And then our MOE, same thing, we're going to go ahead and round, so I get 0.128, and that right there will give us our lower bound as well as our upper bound, which I see you already got correct. Now, our point estimate, I see that you entered in 0.329, but over here, our actual point estimate, that's just our value of P, which is calculated right here. So 0.273 is the correct answer. Now to get our error bound for the proportion, all we're doing right there is taking the margin of error, and that's our error bound proportion. So our rounded error bound proportion is right there, which is given to us after we round this value right here. So I hope that helps with that problem. Now moving on to this problem, these SAT scores are normally distributed with a mean of 1500 and standard deviation of 300. We are also given the margin of error, where we're using a 98% confidence interval, and we're using the margin of error of 15 points. We're trying to figure out that amount of people that should be in the sample. So doing a problem like this actually involves doing it on the calculator. So we're using a 98% confidence interval, right? So thinking of it like in this, I'm going to take 100 minus 98. That gives me 2. So dividing 2 by each side, we get 1 on each side. So I know that on my drawing here, I will have I got 1% on this side, and I got 1% on this side. So using the calculator, I'm going to go into vars. So I'm going to hit second, go to vars. You're going to go to inverse norm. And your total area is going to be 0.01. Because it's only 1% of the total area under the curve. Our mu is going to stay 0, and our standard deviation is going to stay at 1. I'm going to hit enter. That'll give us our value right there. Now, what you're going to have to do next is take the parentheses. You're going to hit second. You're going to hit this. It's the ons key that we're doing there. And then we're going to hit multiply. Now after we hit multiply, we're going to be multiplying by the standard deviation they give us, which is 300. So multiply that by 300. And then go ahead and divide that by the margin of error in the problem, which they give us to 15 points. So divided by 15. And we're going to have to raise that to the power of 2. So you could go ahead and just hit the square key right there. Hit enter. And that right there, 2,164.757778 will give us the correct answer for a problem like this, which they show to a whole number, so 2,165. So rounding up, that's gives us the correct answer. So I hope that can help you solve these problems, and I'll go ahead and send over the video I used to learn how to do this. But here's even